So main thing is when you want to add two signals, that can be done very easily by phasors. So when you are adding two waveforms, you can do by so many methods. You can plot the waveforms and add. See, if you want to add sine t plus cos t means, what you will do, you will draw the waveform for sine t. So I'll draw the waveform for sine t. This is my sine function. I'll draw the waveform for cos t. See, cos t will start from 0 and it will go like this. So I can add point by point what is the value. That is the first method. I can add the two waveforms by plotting the waveforms, which is very time consuming for me because I need to add innumerable number of points because the signal is a continuous varying rate. I cannot split it into a finite number of points. So I have to add infinite points to get the actual exact answer for addition of two waveforms. So plotting waveforms is very tedious. Using trigonometric identities, I can simplify and then add. That is one possible solution. But using phasors, it is going to be very, very simple and easy technique. So if you are going to use phasors, it's going to be very, very simple and easy technique. We are going to add two signals. See here, I am going to consider a signal I is I1 equal to Im sine omega t. So you know how to draw the phasor for this. The phase angle is not there, so it should be traveling along your positive x-axis, and the peak value is Im1. The aromatic preference represents Im1. This is going to rotate along a circle in the anti-clockwise direction like this. I am have another waveform I2. I2 equal to Im1 sine omega t plus theta 1. The plus theta 1 indicates leading. Okay. So I will be drawing Im2 before Im because I2 is leading your I1. So I will draw Im2 somewhere here and the angle is going to be theta 2 and the angle is going to be theta 1. So this Im2 rotates on its own circle in the anti-clockwise direction. So if I want to add these two signals, if you are going to use first method or second method, it's going to be very, very time consuming. If you are going to use the third method, I can easily find the resultant out of these IM1 and IM2. I'll get IM3 somewhere in between using vector logic, and I can easily measure the angle that's going to be theta 2. So from the answer, I can write I3 will be equal to IM3 sine omega t plus theta 2. So adding the signals using phasors become very, very easy. So definitely when you have two vectors IM1 and IM2 like this, the resultant will always be somewhere in between. So if you trace this I1 and I2 using vectors, you can easily find the endpoint of IM3. So that is easily done using vector. So one advantage of using phasors is, see, phasors and vectors are identically same. In vectors, we don't use angles, we use directions, right? In phasors, we use magnitude. Identically, both are having the same purpose only, okay? So addition of two signals is possible using phasor. That will make your job very, very simple. Is that clear?